community session. So today's topic is CloudHub 2.0. So we're going to deep dive into what are the features and capabilities provided by the CloudHub 2.0. And apart from that, like how to deploy the application within the shared space and the private space. And basically, we will see when to use a private space and when to use a shared space and what are the capabilities provided by shared space and the private space. Okay. I will just start with my introduction. So currently I'm working as a senior solution architect and a community lead at a EPM system. I have overall 15 plus years of experience in the IT industry. I have like working on the APIs and integration technologies like from last 10 years. So I'm a MuleSoft ambassador and I'm a MuleSoft speaker. So I have almost speak in more than 70 plus meetups and any other events. So I'm the also MuleSoft meetup leader for Mumbai, Surat, Nasik engineering student. And I almost organize almost 80 to 90 MuleSoft meetups also. I'm a MuleSoft delivery champion, go-to-market champion. I have almost holding all the MuleSoft certification. And I have almost received more than 15 MuleSoft awards basically. I have most expertise in like setting up and architecting the MuleSoft platform, which include CloudHub 2.0, Runtime Fabric, on-premises, Flex Gateway, API Manager, or any other components related to the MuleSoft. I also publish a lot of videos on the YouTubes. I have almost more than 300 plus videos on the YouTube. I have published around more than 200 blogs. And apart from that, I have also have a lot of expertise in doing CRM integration like Salesforce, NetSuite, and any other integration. And yeah, so agenda, as I already discussed, so there will be introduction, or we have already gone through the introduction. We will talk about CloudHub 2.0. We will going to see shared space. We will going to see private space. We will also have a demonstration part. Before I start with the actual session, I will create a private space because like if once I create a private space, it will take 30 minutes for private space to up and running. So let me create it before I move into the actual session. So for creating the private space, like you can like log into the Anypoint platform. You can from in Anypoint platform, you can go to the runtime manager. In a runtime manager, you will see something called private space. I will talk about the private space. What is that a private space? So you can simply create a private space and I can give some name like, if, or something like, test PS dem or test demo PS. Is just a name. I will just create it. So now I have created the private space. You have to create a private network, or right? So I will create it. So the first thing you have to select the region and you have to select the CIDR block. So why I'm creating in the private space right now? Because it will take 30 minutes for a private space to up and running. So I will just provide once CIDR mask. Okay, I just provide 192.168.0.0/22. So MuleSoft generally recommended to have a block size of the 22 for this private space, and 22 will provide around like 256, 500, 1024 IP addresses. So I will simply hit on click button, create button. So I've created in US OYO region. So it will take up to 30 minutes. Okay, so I can move back to my presentation part. So like what is a CloudHub 2.0 and like how it is differ from CloudHub 1.0. So with CloudHub 2.0, you can deploy your application in the containerized environment, which is a Kubernetes based. So MuleSoft running a runtime fabric manager or maybe Kubernetes in the cloud basically, and it's a completely managed service. Like you don't have to worry about high availability, resilience, fault tolerance, disaster recovery, right? Those kind of things, you don't have to worry about those things. Basically, it will be automatically taken care by the MuleSoft. And also you don't have to worry about the load balancer scalability. Basically, we will talk about like how the load balancer gets scaled basically. So here in CloudHub 1.0, like what happens when we deploy the application, right? In the backend, what it does. So it will create a virtual machine. The virtual machine is nothing. It's a EC2 instance, right? It is a EC2 instance. So if you are selecting one worker, it will create a one EC2 instance, and it will set up the Linux operating system on that EC2 instance. Then it will set up JVM, Java basically. Then it will set up monitoring agent, and then it will set up Mule runtime, and it will set up the application on the top of it. Like that is how the application get deployed in the virtual machine or EC2 instance. In containerized, also the same thing happen. But if you see the containerized is bit lightweight as compared to the EC2 as compared to the virtual machines basically, right? So here also again, when you are deploying your application on Kubernetes, right? So it will create a replica. It can create one replica, it can create two replica. It depends like how many replica of the application you require. But in CloudHub 1.0, we call as a worker. Here we call as a replica basically, right? So you can, once you select one replica, so it will set up a one instance of your application basically. It will set up the operating system. On the top of operating system, it will set up Java or JVM. On JVM, it will set up mule runtime monitoring agent, then it will deploy your application. But as I mentioned, the container is it's a lightweight, but there are other advantages as compared to CloudHub 1.0. We're going to discuss on that. So in CloudHub 1.0, you can either deploy the application in the private space and the shared space. So shared space is a multi-tenant environment. So basically, you don't know like where your application is getting deployed. You know the reason, but what on what IP address or no what IP address it will take, or in which space your application will be deployed. So you are not aware of that. It's a multi-tenant application basically, right? Not a multi-tenant application, multi-tenant space basically, or multi-tenant integration platform as a service. So the any other customer or client of the MuleSoft or tenant of the MuleSoft can also deploy the application within the same space. Basically, your application will be in the same space. The other client application can be in the same space, right? But it doesn't mean the data will be shared across both the application, or other client can view or edit your application. It will not going to happen. It will be isolated, but they get deployed in the same space. Basically, you don't know, like, in private space, you can restrict it. So you can define your own IP range. So we have already defined our own private IP ranges, basically, which is CIDR mask. So where we can deploy our application, we know. So this is my space. No other tenant of the MuleSoft can deploy the application within that particular space. It's only you going to deploy in that particular space, basically. It's a container-based application isolation. So where in virtual machine, we are getting the isolation on the basis of virtual, in CloudHub 1.0, we are getting the isolation on the basis of the virtual, on the basis of VMs. Here we are getting the isolation on the basis of container, basically. It's available in the 12 regions across the Europe, United States or Canada and Asia Pacific. Here, like one of the main advantages, it's allow you to select a more granular vCore options. So for maximum vCore, you can allocate it to one replica. It's 4 vCore, and minimum you can allocate it 0.1 V, and like you can go up to 0.2, then 0.5, then 1, 1.5, 2, 2.5, 3, 3.5, and 4. So this kind of options are available in the CloudHub 2.0. Whereas in CloudHub 1.0, minimum is 0.1, then 0.2. Then it directly go to 1. We don't have a 0.5. From 1, it go to 2. 2, it go to 4, 4 to 8. And maximum you can allocate, that is 16 vCores to one worker, right? But here we have a more granular options, basically. Here in CloudHub 2.0, it support Hazelcast clustering. Basically, like if you are deploying a replication on multiple replica, so you can enable the clustering for those two replica. So generally, when you will going to enable the clustering, whenever you want to share the data, like object stored data, or whenever you want to share the VM queues, right? In such cases, you can enable a cluster mode, basically. And for enabling the cluster mode, you require a minimum of 2 replicas. It support a rolling update and a recreate deployment model. So whenever you deploy your application, you can mention whether you want to deploy the application with a rolling update or recreate deployment model. With rolling update, you can deploy the application with a 0 downtime update. But with recreate, no. You will require some kind of downtime. So in rolling update, what happens? The older instance of application will exist till new instance of application gets successfully deployed. Once new instance of application get successfully deployed, the older instance of application will be deleted. In case of recreate, when you are trying to redeploy the application, the old instance will be deleted first, then the new instance will be deployed, basically, right? So here you are not achieving the 0 downtime updates in case of recreate, but generally recreate is much faster, basically, right? It's faster than rolling update. You can easily scalable. So you can easily scalable your application by increasing the number of replica. So by increasing number of replica, you can achieve the horizontal scaling, and by increasing the replica size, you can achieve the vertical scaling. and you have an ingress load balancer on the top of your application, which is auto scale. That is completely managed service. It's completely managed by the MuleSoft. You don't have to worry about any ingress load balancer or any configuration related to ingress load balancer. It will be completely managed by MuleSoft, and it auto scales basically. So like it depend on number of requests, right? It like number of requests. So it auto scales basically. It like it automatically increase the resources of your load balancer. It supports the features like intelligent healing and the zero downtime update, which we have discussed. For intelligent healing, let's consider when I'm deploying my replica within the region. So each region may have a three availability zone, right? If some of one of the region, one of the availability zone goes down, the replica will automatically restart in another availability zone, basically. And even if your replica is got crashed due to some memory issues or memory leakage or any other issues, like it can be anything, like no, it will automatically retry to recover that particular replica. It support it's like so this similar features are available in CloudHub 1.0 also. So CloudHub 1.0 it support intelligent healing and the zero downtime update. It store up to 200 MB of log data, so if you see in CloudHub 1.0 we can store up to 100 MB of data or 30 days, whatever comes first. Here we have something called 200 MB of log data. Let me talk about the shared space. So shared space is nothing like it's a space where you can run your MuleSoft application. And shared space is nothing. It's a multi-tenant space where the multiple tenant of MuleSoft can deploy the application basically, right? So within that particular space. So that particular space is shared by the multiple tenants or multiple clients of the MuleSoft. But it doesn't mean your application will be visible to other client. It will be visible in your platform only. It cannot be visible by the other, or your data will be not shared with the other application. It is secured, right? But questions comes like when to use a shared space, right? So whenever you don't have a requirement of any custom domain or vanity domain, like by default, whenever you deploy the application to shared space, it gives something like application name dot some unique ID dot sard ID dot cloudhub.io, right? So every time you deploy the application, it give a new URL, right? But if you want to host everything into the single domain, right? In that case, you cannot use the shared space. But you don't have that particular requirement, you can go with the shared space. Whenever you don't have a requirement of mutual authentication or custom certificates to configure on your API endpoint, in that case, you can go with the shared space. Also, whenever you don't have a requirement to access the resources which is behind the firewall or which is available on the corporate data center or on-premises data center, right? You can go with a shared space. And also, apart from that, you don't have a requirement to get a private endpoint, right? So you may have a requirement, you want to access your application within the intranet. It should not be accessible outside the intranet, right? In that case, like, but if you don't have such a requirement, you can go with a shared space. And when not to use the shared space, it is just a reverse of like when to use the shared space. So basically, whenever you have a requirement of mutual authentication, custom certificates, or vanity domain or custom domain, right? Or whenever you have a requirement of like private endpoints, basically. So basically, you may are implementing the three-tier architecture like system API, process API, and your experience API. So generally, a lot of people want their process API and system API not be accessible to over the internet, right? In such case, we may require the private endpoint. We don't require the public endpoint for those applications, right? So in such case, you have to go with a private space. You cannot achieve this with a shared space. Or the main thing, people go with a private space when they want to connect the resources. Let consider your database might be located in your corporate data center or on your on-premises data center, or maybe located on any private or public cloud which is not directly accessible or which is behind the firewall. In that case, you cannot go with a shared space. You have to go with a private space basically, because private space provide the capability of creating the VPN, virtual private network, between your CloudHub 2.0 and and for your on-premises data center. Any question, Stan? Anything like before I move further?
Maybe one question about, it is. So it looks like CloudHub 2.0. It looks like managed runtime fabric environment, right?
Yeah. So in backend, it is using the runtime fabric, like whatever features provided by RTF, right? So similar kind of features provided by the CloudHub 2.0, like supporting the clustering deployment models, like, yeah, but there's a one feature is not available with the CloudHub 2.0, which is available in the RTF, which that is the CPU bursting. In CPU bursting, like you can just show like what is the CPU limit and what is the reserve CPU. So those kind of things cannot be allocated here. Basically, here you have to directly allocate the cores, basically, right? Yeah, that is one feature which is not available. Apart from that, like in RTF, you can have a persistent gateway, right? So like if you want to enable the persistent clustering, right? So you set up the persistent gateway, but here on CloudHub 2.0, you don't have that particular capability where you can go and just set up the persistent gateway to make, your object store persistent, your VM queues persistent, basically. Yeah, but it has been built on the same line as a RTF, basically. So in the background, it is running the RTF, basically.
Okay, thank you. Let's go
So
further.
yeah. So this is the typical architecture of the shared space. It's a vanilla architecture, right? We don't have to do any changes. We just have to create the environment, right? And just keep deploy the application. We don't have to do anything. We don't have to customize anything here, basically. So what we will just create the multiple environment as per our requirement. So whenever you will deploy the like application in any of the environment, basically, right, it will automatically, like, it can be accessible via the ingress load balancer. By default, all the endpoints are public, basically, and you can use the API manager in the same way by, you can peer the API manager in your CloudHub 2.0 runtime manage using API proxy or API auto discovery, basically, right? It's the same like what we are doing in the CloudHub 1.0, but only the difference in CloudHub 1.0, we have a shared load balancer. Here we have an ingress load balancer, but I will say it is again the kind of shared load balancer also, like multiple tenant of the MuleSoft can sharing the same load balancer, basically, right? Yeah. But as I mentioned, this shared load balancer auto scales, basically. Okay. Okay. Go to next slide. Now I will come to the private space. So most of the people might be aware, like Anypoint virtual private cloud in the CloudHub 1.0, right? So as the private space is also similar to Anypoint virtual private cloud, but it is improved version as compared to the Anypoint which VPC. I will tell you why it's an improved version, because like I will tell you what we does, like when we are creating Anypoint virtual private cloud in the CloudHub 1.0, right? So to receive the external traffic, right? So we need to create a Anypoint dedicated load balancer on the top of Anypoint VPC, basically. So through which we can get the traffic, and like that traffic can be routed to the application via VPC. Right here we have some concept called private endpoints and the public endpoints, or we can call this as an ingress load balancer, a private ingress load balancer or public ingress load balancer. I will going to discuss in the deep about this, right? So the private space, it's similar to Anypoint virtual private cloud in the cloud hub, right? It is nothing. It's isolated, or it's a separate network, within your Anypoint platform. So basically, when you are creating the private space, that private space is dedicated to your organization. Basically, no other tenant of MuleSoft can deploy the application within that particular tenant, right? So you can create a multiple private space, or you can create a single private space. You can map as many environment you want, as many business group you want, right? So that kind of rule you can set up when you are setting up the private space. I'm going to show that you. The first step, when you want to create a private space, you require a CIDR marks. So for that, you have to do this CPU sizing, basically some kind of sizing we have to do. Like so, no, so CIDR sizing, like we have to do the CIDR sizing, or I can call this as a private space sizing. Like, it depend on number of application, like, how many workers will be there, how many cores will be there. Like, so we have to do some kind of calculation for come up with this particular CIDR mask. So minimum CIDR mask support is /24, which provide 256 of IP addresses. Maximum, I think it supports /16, which provides 65,536 IP addresses. Then we have a 23, which provide 512, and recommended CIDR mask is /22 by MuleSoft, which provide 1024 IP addresses. So whenever you are deploying your application, let's consider I'm deploying my application on one worker, right? So it will select one of the IP, a private IP from that CIDR mask. If you are deploying on the two worker, then two IP address will be selected. Okay. So when to use the private space? So whenever you want to connect your on-premises resources or corporate resources or any resources which is behind the firewall, right? In that case, you have to go with a private space because private space provide a capability of creating a virtual private network or the transit gateway. But a private space doesn't support AWS Direct Connect and the VPC peering as a cloud up to in the cloud, like a cloud up to 1.0. So cloud up 1.0 support VPN, transit gateway, AWS Direct Connect, and the VPC peering. So we have a 4 network connectivity options, but here we have a 2 network connectivity options basically, VPN and the transit gateway basically. Okay, so apart from that, whenever you have a requirement where you want to you don't want your API to accessible outside your network, right? Or it should be accessible within your network. You can go with a private space. So you have a capability where you can enable the private endpoints basically, right? So apart from that, whenever you have a requirement for mutual authentication, whenever you have a requirement for vanity domain or custom domain or custom certificates, you can go with a private space. Apart from that, a private space provide you to configure 80 inbound rule and 80 outbound rules, basically firewall rules, basically. So with any point VPC, you can just configure few inbound rule, basically, not an outbound rule. But here and here you can up to 80 inbound and as well as 80 outbound rule, basically. This is a typical architecture of a private space. So where in the private space you can see basically, so here we have done a lot of customization. So basically I have a customer like where he have some services running in the AWS cloud and within some VPC. And also that particular customer have some databases and some services running in the corporate data center, which is not directly accessible over the internet, right? And even AWS, the service which is running in the AWS VPC, that is also private, right? So in what I will do, and also they want to also connect the Salesforce. For connecting Salesforce, we don't have to do anything. By default, when you are creating the private space, right, the public internet is enabled. So you can see the internet gateway is enabled, right? For connecting the AWS VPC, I can use I can create a transit gateway, between AWS and your private space. For connecting the on-premises data center, I can set up a VPN IPsec tunneling basically between your private space and your on-premises data center. But I guess I have other way. Instead of managing that many connection here, what I can do, I can create one transit gateway in AWS. If you have a AWS account, you can create one transit gateway in your AWS account, and that transit gateway will connect with the on-premise data center. The transit gateway will connect to the whatever VPC available in AWS. In future, if any new data center is coming, right? So you can just create the connection between transit gateway and that new data center, and you can create a transit gateway attachment in like in the CloudHub 2.0 private space, and that transit gateway attachment will connect to the transit gateway which we have created in the AWS. In future, if any new connection needs to be made, we don't have to do any changes on the CloudHub 2.0. So thus we have to establish the connection from transit gateway to that particular entity. That's it, right? So with a single connection also you can achieve that many things. Everything will be like routing the request to the right destination will be taken care by the transit gateway in the AWS. So generally transit gateway is also known as a cloud router basically, right? So it can connect to the Azure cloud, it can connect to your on-premises data center, it can connect to the VPCs, it can connect to the private links. So there are many things, right? Yeah. Okay, so let me check if my VPC has been, my private space has been created. Yeah, that's good. So here my private space has been created. Now we will walk through each and everything. So it is created like, it is, let me check, let me refresh it. It's creating it, but let me copy this public DNS. You can see there are two DNS. This is not a user friendly DNS, but it's there. So let me copy this and I will just go to CMD. I will say NS lookup. So here you can see it resolved with the 3 IP addresses, right? So these are the 3. It should just a minute. Still it is setting 3.130. Yeah, still it's there 3.130.8.32. Then we have something called 18.88, like one. So why we have a 3 IP addresses? Why we don't have a 1 or 2? So 2 is enough for high availability purpose, right? But why 3? So I will tell you, if you are creating a private space in that particular region, if that particular region have a 3 availability zone, you will see the 3 inbound IP addresses here, right? If it have a 2 availability zone, then you will just see the 2 IP addresses here. Same thing goes with the outbound static IP address. So again, we have a 3 availability zone. So you will see the 3 outbound static IP address. So what is like what is the use of outbound static IPs? Right? So I will tell you in CloudHub 1.0, let example, I will just explain with the scenario. So in CloudHub 1.0, we have a concept of static IP. So how many static IP we get? So depending on like 2 into number of production vCores. So if you have a 2 production vCores, you will get a 4 static IP address. So what is the advantage of static IP address? So let's consider I have deployed one application in the CloudHub 1.0, right? So I've simply deployed the application in the CloudHub 1.0, correct? So in that case, like that particular application has to communicate with some SFTP location. And like for that particular SFTP location, we need to whitelist the IP address of that application that needs to connect with that SFTP location, right? So by default, whenever we deploy the application on the MuleSoft, the IP address allocated to that particular application is dynamic. If application get restarted, the IP address will change. The public IP address will change. If application is redeployed, the public IP address is changed, right? It's not a good solution. Like every time we go and just whitelist the IP address in the to the destination, like where IP whitelisting is needed. Even in case the application restarted or it moves from one availability zone to another availability zone automatically, right? In such cases, IP address will change. So we have a concept called static IP address. So we can assign a static IP address to the application. So while deploying the application, and that particular static IP address can be whitelisted at the destination. So the MuleSoft application can communicate with that SFTP location easily. Like, and that is static IP address doesn't change during the redeployment or restart or anything. That will only change if you are deleting application and redeploying, then only change. Otherwise, it will not change. But the problem is that like if I want to whitelist 10 application, right? So I need a 10 static IP address, but by default, you have been provided with a 4 static IP addresses basically, right? So what MuleSoft has done in this particular private space, it have a static IP address enabled at a private space level basically. So whenever any application want to communicate with the external application, right? So they will going to use these outbound static IP addresses. So what you have to do whenever you want to communicate with any application where IP whitelisting is needed, you just simply need to whitelist these 3 IP addresses. As simple as that, right? Apart from that, you can see the route table. So if you don't want to have an internet connectivity for your application, just remove this internet gateway route from the route table. So, but it doesn't. It is not recommended. If you are doing it, our application will not able to communicate with API manager, Anypoint MQ, or many platform services, right? So it is not recommended to do that. Okay. So apart from that, like here you can see we have a something like by this is the default key store which contain one private endpoint and the one one public endpoint. I will create my own TLS content because I require my own vanity domain. So I will say dev TLS. I might be having the JKS file, hopefully. So let me go to desktop. Yeah, this is my dev key store. I just have to provide the password for my key store. Okay, the domain is API dev domain name.com. Then I will provide. Okay. Apart from that, like you can also add the client certificates if you want to enable the mutual authentication, right? So if you want, like if you are communicating with some client where mutual authentication is there, you can just add the certificate and I will just say create TLS. Okay. So now other thing like I will add one more. So here I have an API domain. I need to add for QA also. So I can say QA TLS. Okay. Okay. So I have added two certificates. Now, like how how to do the mapping in it. Like now I want this particular domain. So just adding the certificate is not enough. You need to do the DNS mapping, right? In the registry, like between A record and the C name. So what we have to do? So like now I have this particular domain. I will copy this on some notepad if I have some notepad here. And I will call this as a C name, right? So this is my C name, right? And I have to map this particular C name with this A record. Yeah, this is my public one. So this A record. Okay. Same thing goes with the QA. So you can just, map your QA environment also in the DNS registry. And this is my C name. And this is my A record. And same thing you can do with a private, with a private endpoints basically. Like we have something called private endpoint, so you can have a API dev hyphen internal basically. So you can use this particular endpoint. This is my A record for the internal request basically, and you can add more certificates for internal endpoints basically, and just do the entry in the private registry. So yeah, so that's how you can do it. Here we can define a firewall rule. So here you currently, if you see there are two inbound firewall, it is allowing all the HTTP traffic and all the HTTPS traffic. It support many other protocol like ICMP and everything so those kind of if I say add rule, it support TCP. ICMP is also there. I'm not able to see it today, but it is there basically, right? Yeah, outside, yeah, it's there. So up to 80 firewall rules you can define, and again up to 80 outbound firewalls you can define. Environment right now I just have a map the sandbox environment. So my sandbox is mapped with the QA and the dev environment. And here you can see a business group and its children. If you want to map all the in any environment in 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 all the business groups, just select this. Or if you want to select it some business group, you can just select it here. Now I will go to advanced. So this is like configuration for my ingress load balancer. So here you can define how, like what kind of request needs to be accepted and what kind of request need to be uh, uh, need to be rejected, or how the request needs to be redirected. So here I can say HTTP request redirect to the HTTPS. Even I'm getting the request on HTTP or HTTPS, it will always redirect the request to the HTTPS. It means your application must be running on the HTTPS. It will accept HTTP. It will only accept the HTTP. It will drop the HTTP. It will accept only HTTPS and drop all the HTTP requests. Here, like read timeout between your ingress load balancer and your application, which is by default 5 minutes. You can increase or you can decrease. Here, ingress load balancer have a capability where you can download the logs also, whereas on dedicated load balancer, you cannot download any logs, and you can define what kind of logs you need to download, info, error, debug, trace, and also what from which IP address you need to download the logs. You can define that also. So this kind of capability provided by the private space ingress load balancer, right? So let me go back, and I forget to explain this one thing. Internal DNS service. What is this internal DNS service? So let's consider whenever you want to resolve any domain with any IP addresses, right? So you can just put IP address and your domain name. If there's any second IP and domain resolution, you just put the comma space and put the second IP address and the second domain name. It's kind of host entry, like on Windows machine we do under the drivers etc host file we do that entry, right? So here you can that within the private space, if you need to resolve any domain with particular IP address, you can do that. We can just save it with here basically. So yeah, okay. So that is about a private space. So what we will do, I will create one simple application quickly. So we have 7 minutes. Okay, so I will just say mule demo rules finish. Right, by default it support only 8081 port for HTTP, HTTPS traffic. Doesn't matter whether it's a private traffic or like public traffic. Like in CloudHub 1.0 we have a four ports, right? 8081, 8082, 8091 and 8092. Okay, so let me bring a HTTP listener. I'll create a simple application. Let's say let's just say test, and I'll just use one transform message, a simple transform message which is success. I can say a response. Okay. So let me save this and export it quickly. Yeah, it should be exported. Just say desktop, save, finish. Simple. So what I will do, I will just get into my platform. I will go to application. You can deploy the application in same way you are doing for the cloud of 1.0. Just click on deploy. I will say mule test cross shade. Okay, here by default it taking the private space. I don't want to deploy in private space. I will just deploy in the shared space. Just choose the file. Okay. Here you can select the runtime version. So like minimum runtime version supported is 4.3.0 and above, like, and apart from that ingress. So like I'm going to discuss on that part. So here you can deploy replica size, replica count, and deployment model. So by default, run in the cluster mode is disabled. If I select two replica, it will enable it. And you can just you can cluster the application. You can use the object store too. So deployment model, I will just keep a recreate, but it's a first time deployment, doesn't matter, right? It will be work as a recreate only. Okay, so I will just deploy. Any question? Like I can take it. Okay, so like I will migration consideration basically like so when what are the things you need to consider? So first thing like as we discussed, it provide a granular vCourse option where you can deploy the application on the smaller vCourse basically. It also provide it also have a support for any point clustering basically, right? And like you can also choose whether all your message needs to be processed by primary node or all your message needs to be processed by both the node, or also you can make use of the VM queue to do load balance the request between the nodes basically. It also have a like more control over the security basically, like you can have a inbound as well as the outbound firewall rule basically. Yeah, it doesn't provide application insight like CloudHub 1.0. In CloudHub 1. Sorry, in like CloudHub 1.0. In CloudHub 1.0, like you need to create a two dedicated load balancer, right? For internal traffic and for the external traffic due to some security reason, right? So I have, so like I cannot explain. It will take another 30 minutes. So there are some kind of constraint. So we need to create a two dedicated load balancer for internal as well as for the external request, basically, right? But here in CloudHub 1 2.0, we don't require to do that. We have a single ingress load balancer, basically, which is MuleSoft managed. But what you can do to stop the public traffic, you just remove the public endpoints from the application, basically. You just keep the private endpoint. I will going to show that in the demo. CloudHub 2.0 supports 4.0 and the above version. It only have one port, 8081, which is supported, no other port. If you are trying to deploy on any other port, you will get a bad gateway 502 error. Yeah, it doesn't support a few features like data graph, VPC peering, AWS Direct Connect, persistent VM queues, built-in custom notification, CloudHub connectors, TLS 1.0. I think URL rewriting is supported now. So why CloudHub 2.0? As I mentioned, it's like uses the Kubernetes based architecture, and whenever you deploy the application, it get deployed in the lightweight container, basically, right? Which can be easily scale up, which can be easily scaled down, basically, right? Apart from that, like your ingress load balancer is like it auto scales, basically. You don't have to worry about scaling part, right? Apart from that, here you don't have to manage the multiple dedicated load balancer for internal and the external traffic. You can in CloudHub 2.0, you just enable disable private public endpoint and you can achieve that. And here you can set up multiple inbound as well as multiple firewall outbound rule. So you have a more control over your input and output request here. And like it provide a lot of built-in security, and like all your communication is encrypted basically. Here, this is the typical architecture in API-led connectivity basically. So here, like I have system API, process API, and the express API. My system API and process API doesn't have to be exposed to the external client. So I just have a private endpoint on my system API and like public endpoint on my the express API basically, right? So let me complete my demo. Say it is deployed. Let me go to settings. Okay, so here you can see that this is my URL. So in URL, like if you see in CloudHub 1.0, your application name must be unique across the control plane, right? Doesn't matter which client is deployed. Let's consider I have deployed one application with name mule test, right? The other client cannot deploy the application with the mule test because the application name must be unique across the control plane. Here, MuleSoft has resolved that particular issue. So you don't, your application name must be unique across the environment. That's it, right? So what it does, it adds the 6-digit unique ID and 6-digit SART with some 1, 2, 3 value basically. I don't know how it calculate this 1, 2, or 3. So, but it add it. And then I will just say test, right? So I got the successful response. Let's do, I will deploy the same application on my private space basically. I'll copy this name, deploy PS. So by default, it select my private space. I'll choose the same file. I'll choose everything same. Rolling update, nothing ingress, no properties. Here, like you can see the ingress, you can add like your own ingress. This is the default ingress. Let's consider I want to add like some custom domain here. So I can simply select API dev domain.com. Like we have created the T-Rex context for that, right? Like this is my dev environment. So I will just select the API dev domain name.com for this. If it has been QA, so I would have selected the QA basically, but it's a dev. But this URL will not work because we haven't done the DNS registry yet, but I will keep it, right? And by default, it will create a private endpoint also. You can see it here, right? So mule test project, and this is the URL which we have seen in the private space. Just save deployed application. So I will copy this private endpoint quickly till it's getting deployed. I want to do one more thing. Last thing, it's just 2-3 more minutes. Okay. So what I will do, I have to create one simple application. So I just copy the private space basically. PS test and HTTP listener. I just bring the requester. In request, I will just put this private space URL and I will just say test. Right here in HTTP, I will just go in. I will just say test one. So let's consider this is my experience API, and in request it is calling my system API. Let's consider this. I'll just save all. Like export. So let me go if my application got deployed. So it is still deploying. Let's wait. Apart from that, till like I want to explain one more feature. It support the last mile security. This is supported for private as well as the shared space. So last mile security means like your like communication between ingress load balancer and application must be the HTTPS basically. So right now I cannot enable the last mile security because my endpoint is on the HTTP, right? So yeah, to do that you have to configure the HTTPS listener here. Then you can enable the last mile security. So let me see. I have like a lot of URLs because I selected many URLs. So right now, what I will do, I will try to, the API domain will not work. That's for sure. So I will use this one. So test. I see I got a successful response basically. But my question, I don't want to get the response from the public endpoint basically because this is my system API. So I will remove all these endpoints. Right, and I will just say apply changes. Till it is getting applied changes, so I will deploy my other application, which is my experience API. Yeah, test exp API PS. I will just deploy this into no like say I haven't exported yet. Let me export. Okay. Okay, so what I will do, deploy application ingress, everything is good and just deploy. Till it's getting deployed. This is just 2 more minutes. I will be finishing my demo. Yeah, let me. This is the one. Here you can see like your public endpoint is the remote. And let me try to like use private endpoint. Okay. Will it work or not? Let me do that and test. So what I've done, so I've deployed one more Express API in the private space, and I'm just calling this URL, right? If they are will be in the same space, then they can call this private endpoint. So currently it's not working. So what I will do, this is the project. Test not I want experience API. Yeah, it is running. I will just say test. What was the test one? I think. Yeah, we got the response. Now this API able to call the private endpoint because they both are in the same private space. Now few more tips like, so let's consider if I have a multiple private space and how can I connect the multiple private space? So you have to create a transit gateway in the AWS and that has to be attached in the MuleSoft to connect those two private space. So basically you have to create a transit gateway to enable the communication between the multiple private space basically. Like in CloudHub 1.0, we are using the VPC peering to enable the communication between multiple VPC. Here we have to use the transit gateway, and transit gateway has to be created in your AWS, right? And that can be attached into the CloudHub 2.0 private space, basically. Yeah. Any question? Like I think I have covered almost everything. So thank you.
Thank you, Jitendra. It was an interesting discussion, and I would ask, feel free to ask your question. Gabriel, please unmute yourself and ask your question.
Dear colleagues, great session. Jitendra, thank you so much. My question is the following. Keeping in mind that private space maintains you isolated from other customers' world looks like. The same for Runtime Fabric. And additionally, Runtime Fabric has a pay-as-you-go model, cost probably even lower than private space, right? That normally is more higher.
See, runtime
what
fabric
would
is
be,
this.
yeah,
Gabriel, go on. Yeah.
what would be your recommendation in terms of cost management and operational aspects, keeping in mind those particularities, right?
Okay. See, it depends, like, what happen if you are setting up the runtime fabric manager, right? RTF. So like you have to like come up with your own infrastructure, own hardwares, basically. If you are setting up on premises or corporate data center or on the bare metal. So you are responsible for managing the complete infrastructure and everything. Like you are like responsible for creating your own ingress load balancer, like how the ingress to make sure your ingress load balancer is highly available. In case if you are setting up Kubernetes RTF on the AKS or self-managed Kubernetes or EKS or GKE, basically, right? So here, here again, it's a customer responsibility basically to take care of everything, so like infrastructures, basically, like only MuleSoft will only take care of your Mule runtime and the Mule runtime, basically, right? When they provide the RTF, right? In case of this CloudHub 2.0, so they will manage everything like backend infrastructures, like your ingress load balances automatically, like auto scales, basically, right? In terms of operation, right? The CloudHub 2.0 become bit easier, basically. Like if you are going with a CloudHub model, basically, but apart from that, you need to consider a compliance also, security measures also, like what policy does your organization support, like what kind of compliance rules within your organization. If some organization doesn't want to go with to the cloud, basically, right, that they would like to be then in such cases, like you can go with the runtime fabric manager on like AKS. Again, you are going on AKS, so you are again on the cloud, basically, the only thing, the AKS will be managed by Azure and EKS will be managed by AWS, basically, right? So Gabriel, this is completely, depending on like what's your organization policy, what you want, right? So it is always true. Like if you are going on the cloud of 2.0, so it's everything will be like you don't have to worry about a lot of management thing, like lot of operational thing, like it automatically it will be automatically handled, right? So you don't have to worry about like zero downtime updates and all those things, basically. Even I think on RTF it also provides zero downtime updates and everything at auto, but like main thing with RTF, you have to be like you are responsible for managing uh hardware, infrastructure, like security, high availability, everything.
Thank you for the question.
Yeah.
Thank you for the answer. Any other
Anything?
questions? Fine. Looks like everything was clear. Thank you, Jitendra, for great session.
Yeah.
Thank you all for participating in this session. Oh.
Thank
Thank you. Have a good
Thank
day, have a good evening, have a good morning.
Yeah. Thank you so much. Bye bye. Have a nice day.
Good session.
Bye.
Bye.
Thank you.